Hello everyone. Today in this video, we are going to start jumping into the internal parts of the computer. So we have covered, your basic hardware, networking, and now we are going to get more into the software side of things. So that would be looking into the operating system and how software is managed in your computer. So, first, before you get started, I just want you to kind of think of it like this. So, you have your softwares, also known as apps. They're basically can be interchangeable with the name, but you have your software or your apps, and just consider those your actors of the theater, right? And then you have your operating system, which is going to be the stage manager. So, if you were to put on a play, your computer is technically the theater that houses both actors and the stage manager, whereas your apps are the actors. They're the ones that are delivering what you see, the experience. And then your operating system is the stage manager, which is basically the people in the background that make sure that the actors are doing what they're supposed to be doing and everything goes smoothly. So technically, they are interchangeable. Without an operating system, the apps would not be able to do their job. So, an operating system is actually a software, but that software is what manages how your computer interacts. So that would be, how are your hardware parts interacting with each other? How do they interact with software? And how do users interact with them? So although the operating system is a software itself, it's basically, you can say, the primary software of your computer. Without that software, the computer would just basically look like a terminal view or your command line interface view if it did not have it. So, why do you need it? It's basically the management of your computer. So it's going to manage your hardware. It's going to say, okay, this app needs this hardware. This hardware needs to connect to this hardware for this to complete. It also runs your apps, and it provides you the actual interface that you see. So the visuals that you see on your computer is all made from your OS. So if you think about it, when you boot up your computer, you typically see that symbol. So that symbol, depending on what your OS is, it'll show up first, and then your login screen will show up after. So when you see that symbol show up based on whatever your computer is, that's basically your operating system turning on. So sometimes if you've been to your computer, you plug it up and you don't see any symbol and nothing's happening, then that could either be a screen issue or an operating system issue. So the common operating systems, which many people know the first two, which would be your Windows or your Mac OS, which is your Apple computers. Windows seems to be common within the gaming community, as well as companies, and as well as everyday use. Apple has the Mac OS. There is Linux. So some of you may not have heard of that. That's the penguin icon over there. Linux is a operating system that you can put on your computer for free. So technically, you can have a Linux system built into a Apple computer or a Windows computer through virtual machines, or you can have a designated computer that runs Linux. So Linux is very much similar to Windows. They're pretty much very close to being siblings. They do the same thing. They kind of look the same way. But those Linux users out there are typically in the dev environment, or they're heavy into computers. So for the everyday computer user, you probably would not have heard of Linux. And then other operating systems, as far as mobile goes, would be Android and iOS. So Android with Samsung, and iOS obviously is with Apple. So now that we've covered those operating systems, they all have similar functions, and all of these functions occur in every operating system. So you basically have your processing, your memory management. What that means is every time you run something on your computer, it's a process. So it's running whatever you're asking it to do, and it basically has a process per task you are giving it. Now, each process also would require a certain amount of memory, um, RAM memory. So to see how much is it going to take for us to run this application at this time. So, being that many times when you're on your computer, you're running multiple things at the same time. The processes are just managing those processes, and the memory is just managing how much space those processes are using. So, again, for example, if you have a lot of applications running in the background, your computer starts running slow, that probably means that you have too many processes running and they're taking up too much memory. So, your computer is starting to slow down. Along with your process and memory management, you also have your file system. And when I say file system, that is regarding your actual files that you save onto your computer. So, documents, downloads, etc., your normal file explorer or folders that you have on your computer. And then your device drivers. So, that's just connecting various devices to your computer. So before we get into those overall processes, there's a important portion of information you need to know. So that would be your BIOS and your UEFI. Okay, so basically you have your OS. And there's going to be different firmware interfaces that run before the OS loads, which would be your BIOS and your UEFI. So what they do is they basically check your hardware. So they're checking your overall hardware in your computer to see what it's working with. And they basically run a startup test. So they're testing to see if all the hardware components are running together, if they're running well, and basically how much space does it have, how much power does it have, etc. And then once it runs those tests, make sure everything looks good, it basically passes the functionality to the operating system, and that is when you would see it load up on your screen. So basically, this check process is that very quick um, interaction that you have happening on your computer. For example, when you first press your power button, you don't necessarily always see your operating system logo immediately. There's always like that gap. That's when your BIOS or your UEFI is happening. So they are not the same thing. They are basically this like siblings, but one's newer version. So BIOS is actually considered basic input output system. So that's like your normal interaction with a Windows computer. They have BIOS, and that's what starts the OS. But now there are computers that are starting to move towards UEFI, which stands for United Extensible Firmware Interface. And that's basically just a BIOS replacement, just having you boot your computer quicker, and it has just basically more modern components to help you protect your computer overall. So your computer will have one or the other, and it's basically what's responsible for connecting the hardware to the software when it first starts up. So once it runs the BIOS or UEFI, it goes into what we call a bootloader, which is the program that's actually going to load the OS kernel into memory. So basically, this is what actually starts your computer up, and that's when you start to see that operating system sign. And this, as I said, runs after BIOS. So of course, you're probably like, I don't know what an OS kernel is, but we will get into that as well. So the OS kernel, and for keyword purposes, kernel is going to be the keyword. So make sure you capture that kernel. And your kernel is actually a core part of the operating system. So if you take a look at that diagram, you see the kernel is like in between your software and is also in between your hardware. So it's basically connecting the two. The kernel is responsible for connecting the hardware to the software, and it's basically going to connect each one to each other. So this is going to be responsible for that original OS functionality that I was mentioning earlier in the first slides. So your process and memory management, as well as device management, for example, what type of devices are connected to your computer, as well as your security and access. So the kernel is basically the communication between the hardware and the software. So overall, just to give you an idea of how your operating system starts when you turn on your computer. So you turn on your computer, your BIOS will run, the bootloader will then load the kernel to you, and then basically that is when you will see your OS logo. So those three steps are happening prior to you even seeing your logo appear on your computer. So if you know, when you turn on your computer, it pretty much is typically a 2 to 5 second wait before you see your operating system. Then that is basically how long it takes for those two big major processes at step 2 and 3 to run. Now, if there is a case where it takes a long time for your logo to appear, that means something is potentially going wrong with step 2 or 3 of your computer if your lights on your computer come on. So if you ever have an issue with your computer and it's taking a long time before you see your operating system logo, then there could be an issue with number 2 or 3. So now that we've covered how the computer itself starts using that software or your operating system, there's one thing that you need to know as far as soon as it starts, your computer is basically taking up memory. So it's running those processes as soon as it turns on. So how does it manage it? So you have your RAM and you have your virtual memory. So just think of it like this. Your RAM is your desk space. And when I say desk space, that means when you go to a desk, at school, you sit down at the desk, you take your stuff out. But as soon as it's time to leave, you typically will pack up your stuff and leave. So the same thing happens with RAM. Basically, when you turn on your computer, you would take whatever applications you're running and you place it on your desk, and it's going to be there and it's going to stay there. So then you have the option to pick up this item off the desk, this item off the desk, or remove this item or place a new item. That's what the RAM is like. It's basically just you sitting at a desk and going through different things or different processes. Whereas your virtual memory is like a filing cabinet. So basically when you leave, it's still going to be there. You can go grab it out the filing cabinet and place it back whenever you want to, but it's basically more so, I guess you could say, more of a permanent storage solution rather than RAM, because RAM will basically leave every time the computer is shut off. So um, basically, you are running multiple programs when you use your computer. Nobody just goes to their computer and literally just opens up, for example, Word document. You're not just going to have Word document open on your computer. You probably have Word document open. You probably have a web browser open. You probably have your file folder open, maybe even videos open. You can have millions of things open. And that's basically what you refer to as multitasking. Now, multitasking comes with scheduling, which is basically dealing with, that memory management and that process management. So, how is it going to work? So, basically, what happens is overall inside of your computer, when you run multiple processes, there is a period where they are trying to share time. So, the CPU will basically split time amongst all programs to run it. So it's going to say, hey, for example, if your web browser has, 6 tabs open, then you need a lot of CPU or, your computer processing unit to pretty much run your computer to have those tabs up. Um, and then basically after it splits that time up, you would have the context switching. Basically, it's just saving the state that your application or that process is in. So, for example, when you minimize a web window or any window for that matter in your computer, it basically saves that state. So, imagine if you went to the web browser and you click minimize and you come back the next time and nothing's there, or you have to restart. That would be very much annoying. So, you would have to constantly restart whatever you're doing. So, the context switching is basically saving the last state of when you were using that program or that process so that when you go back to it is there. So that would be the context switching. Process scheduling is just telling which program gets CPU next. So which program is going to require the most running power. And then you have your memory management, of course, which is just managing how each program is running, making sure each one gets the appropriate amount of memory, and trying to make sure that your computer is not overpowering or doing too much to have these programs running. So that's basically what happens when you're running your multiple programs in the background. Um, and many times you don't consider what's going on in the background, you just do it, but this is actually what's going on. So we're going to get into our next keyword, which is file systems. So file systems is basically what you use to store and organize your files. So this would be your file explorer on your computer, where you're saving all of your important documents and photos, etc. So it basically is a translator between raw data and the file names you see. So you see the file names based on what you name them, and your computer will basically have the raw data stored on disk, um, basically binary form of it on the disk. But the file system is basically what makes it manageable for you to understand which each file is and what it holds, etc. So the main functions of that would be obviously organizing your files and tracking where it goes. So you might have a file that goes from downloads to documents or downloads to desktop. Also deals with managing access. For the access component, if you're using a personal computer, you typically would not be so concerned about access of files, because typically only you can access your computer. But in the case where it's a shared computer, such as like a school computer, that would be a situation where access would be a concern. The file system also will manage how much free space you have. So when you get an alert that memory is running low, the file system will tell you that, as well as it will store metadata. So metadata is basically information or raw data that you have about the file, regarding creation, how much data is stored, what type of data is stored. So it's basically just a information sheet about the file itself. So metadata is in the background. Typically you will not see it or interact with it, but it's just basically a big chunk of information regarding the file itself. All right. So now that we have covered your OS, your file system, you also will have the case where you have drivers or device drivers. And these drivers are basically going to help you connect those external hardware components to your computer. So this could be a printer or a graphics card if you, for example, built your computer, or a keyboard or a mouse, etc. So sometimes when you get some of these items, such as a keyboard or a printer, it might say you need to install a driver to be able to use that hardware. It's basically a program in the background that you would install and run to open up that gateway of connection between the hardware and the operating system of your computer. So it's like an interpreter. So it's just saying, for example, if you download a driver, it's saying to your hardware what exactly it needs to do to be able to connect to whatever device it is. So many cases will you see this, not necessarily, but it is possible. And sometimes if you are connecting external components, then you need a device driver. So also you have your software installation. Um, I'm not going to go deep into this because it's pretty self-explanatory. Many times for your software on your computer, you're either going to get it from like an app store, whether that's a website store. You're going to download installers. So anytime you download some software on your computer, it will pretty much have you run the installer. And if you have Linux, they have their system called a package manager, which is similar to pretty much an app store, but for Linux. And that's how you get your software. So typically, you're going to get your software from like the Windows Store or the Apple Store, or you're going to download it straight from the web browser. And of course, every software you use has software updates. And I'm sure many of you are like, I don't know why I have to update my software all the time. When you're on your phone, it says you have to download something as far as an update or even a update for your phone. So when you see those occur, basically what's happening is the three following things. It's going to be implementing security patches. It's going to be fixing any issues or bug fixes, and it's going to provide you with some sort of new feature. Now, that is why, for example, if you have an iPhone, each year there is a major software update, which we are coming upon that very soon. Um, Basically, it's going to see what issues it had in security. So, did somebody find some issue where something happened with their data or something that needs to be addressed? Or is there a glitch? So, for example, when people open this section of their phone, does it always crash or does it run slow? And then a new feature. So it basically will give you something cool, something new, because we all know if we use the same thing over and over again, we get bored. So overall, all softwares will make some sort of new feature. For example, there is no app that has been created that you use that has stayed the exact same. Instagram does not look how Instagram looked when it was first created. The same as TikTok, the same as Snapchat. Each app has basically evolved and changed over time, even down to your web browsers, Google Chrome or Microsoft Edge. There will be times when you load up those web browsers and then there's that pop up page of information that says, hey, your web browser has updated, and then they will give you a blob of information regarding your update. That's basically what's happening. It's just keeping your update up to date with security issues, making sure it's secure, fixing any possible glitches that were in it, and giving you something new that you can use to make your job easier. So, those would be your software updates that you see and have to deal with, obviously, through your phone and computer. And overall, going back into your operating system, you usually have some sort of user account set up. So for many of you, you're just going to have your one admin account. So this would be pretty much the overall account on most of your computers. It's just basically saying that you have full control over the operating system and the computer itself. So that would allow you to install your software, manage any additional users, and change settings, and basically have full control over the computer itself. Now, in the case where the standard users come into play, this would be if, for example, you have a family computer and everyone has their own account on it. So maybe growing up, you had a parent who had a computer and then they had an account for you on their computer. So your parent would be the admin. They're the ones who can install software that can be used by you, and they can manage, what you have control over. And then in that case, you would be the standard user. Another case of this would be any school computers. So the library computers, you have the ability to go in there and log in with your information, but you don't have certain controls to just go in and install anything you want to. So in those cases, you would be a standard user. But the admin would typically be the one who doesn't have to ask for permission just to install any and everything. So for most of you, your laptop, you are the admin. And standard users would just be for, your public device use cases. So with those user accounts, there are certain permissions. There are typically these four permissions that you would have. So as an admin, by default, you would have access to all of these permissions. So reading, writing, executing, and deleting, which they basically do exactly what it says. And this deals with any of your resources or your files on your computer. So basically it's saying, can you read them? Can you write to them or change the file? Can you run them, and can you delete them from your computer? That's basically the overall permissions that are attached with those user accounts. Typically with the admin, you have all of these by default, but there is a case with the standard users that you can prevent them from doing. For example, you prevent them from writing, so they can't modify files or they can't delete files. So there is a case with that. And overall, with your operating system, there is some security features that are in play that you need to consider. So some operating systems come with a firewall, so that would be your protection against, when you're using your computer and connecting to the web browser is sort of a protection barrier. Now, there are advanced versions of firewalls that you can buy, upgrade, etc. But there's a standard one that typically exists in all operating systems, as well as antivirus. So for Windows users, that's like Windows Defender. It's basically also known as Norton. If you see McAfee, sometimes when you buy a new laptop, it'll come with it automatically or a free trial, or you can upgrade it yourself. So if you don't have, virus protection, you can go to the web browser and get some and download it on your computer. So that would be your protection against, people accessing your information, or just a layer of protection to make sure that your computer does not get any viruses on it. And then your operating system will also have encryption. So that's just basically, morphing what um, your computer data has into encryption, making it harder for, if people were to access it, making it harder for them to read. Um, so we've covered that briefly as well. So I won't go in a deep dive on that. But overall, your operating system security is basically making sure that it's protected against attacks and, unwanted viruses. So why does this all matter? It matters because you use operating systems every day if you touch technology, regardless whether it is your phone or your laptop. Pretty much they all have the same processes. Obviously, the phone, you do not see the same processes, but they exist. So, every time you use your device, all of this is going on in the background where your device and your device hardware and your operating system connect to work together to provide the experience you see. And that is why it is important to use. So, your key takeaways for this would be your operating system is the one that basically powers your device. It's the one responsible for showing you everything you see on your device, whether it's your laptop or your computer. It's also in charge of managing that connection between your hardware and your software, as well as how your memory and your files are organized on your operating system. And again, your BIOS or your UEFI, bootloaders, kernels, and your file systems all work together and come together to run and boot up your device. So, overall, now you kind of get a glimpse into the actual operating system that's running on your devices. That is your primary source of software on your device that allows you to use it. So, hopefully, you learned something new. And when you use your phone or your laptop, now you kind of get an understanding of what's going on behind the scenes. Of course, feel free to deep dive further into the operating system that you have on your phone or your device if anything interests you. But if you are the curious one, I would say look into all operating systems, see the difference, and maybe you might find one operating system better than the other, and then you can always, get a new device to switch over. So that is all I have for this lecture, and hopefully you learned something new, and I will see you in the next video.